Okay, fine. Now I want to same example. Same example means similar type of example. Let's assume I have a data set containing the three features x1, x2, and x3. So, and based on these three features, I'm trying to predict a variable called y. It may have a multiple samples values, say 0.1, maybe 0.2, and 0.3, and corresponding value 0.4, and maybe 0.3, 0.2, 0.5, corresponding value 0.6, like that. Multiple samples are the data. Let us do. Now I want to build ANN model, simple ANN model. So simple ANN model without any hidden layer. Only I am trying to increase the complexity of the model just by adding the bias parameter only. Once it was completed, then we will move to some other. So we will try to increase the complexity one by one. Okay. Of course, all the type of architectures already shared with you, their codes, but I am trying to explain one by one. Done. So now, so I don't want to keep any hidden layer here also. So anyone can tell me. So we have the input layer and output layer only. So number of neurons in the input layer. So we have only three neurons in the input layer because we have the only three features. So that is called x1 and x2 and x3. And we have the one output layer because we are going to predict only y. So yp is called as predicted y value. So all are completely interconnected. All are completely interconnected, and these values are called as the weights W11, W21, and W31. Now I want to increase the complexity of the model by adding the bias parameter. So we are going to add the bias parameter for every neuron except the input layer. Except input layer, we will add the bias parameter at every neuron. And we add the bias parameter for the robust ANN construction that able to predict varieties of data. So we are increasing the complexity. That means it will be more robust. Then where we add the bias parameter, so we are going to add the bias parameter at the output layer. And the bias parameter is represented with B. And the input for this bias parameter always 1. For all the W11, W21, W31, signal is passing from the X1, X2, and X3, where the bias parameters, how many bias parameters are there? For every bias parameter, the input is 1. So this is called as the bias parameter. Okay. So for every ANN model, so for any generally ANN contains the both weights and also bias parameters. Even not only ANN, so that will be exist for the CNN and also, but with deep neural networks. In the deep learning case, you can take the deep neural networks, or you can take the CNN, you can take the RNN, whatever it may be. You can see the bias parameter. Okay. So now how many number of model parameters we have? W11, W21, W31, 3 weights and 1 bias parameter, that is called as the 4 model parameters are there for this ANN model. 4 parameters. And again, I am using the linear activation function here also. Here also I am using the linear activation. Only one change when compared to the previous model, that is I am adding the 1 bias parameter. That's it. So I want to ask one question to all of you. If anyone give the answer, that's fine. For example, I want to design a ANN model to predict the load at a particular time of the day, at a particular time of the day, based on at a particular time of the day, based on last 3 hours load data and also last 3 days load data. And I want to construct the ANN model without any hidden layer, but with bias parameter. If that is the scenario, anyone can tell how many number of model parameters the ANN model consists. How many number of model parameters the ANN model will consist? Let's assume, I want to repeat the question once again. Let's assume I want to design an ANN model without hidden layer, but with bias parameter. Okay. So the main requirement is I'm trying to forecast the load at particular time on a substation based on load at last 3 hours and also based on the load at the last 3 days at the same time. Then tell me how many number of model parameters that ANN has. Any idea?
Six.
That number, how many number of model parameters
Hello?
that ANN has? Anyone, please? At least number of neurons in the input layer for that case study.
Parameters. Six.
Number of neurons in the input layer.
6. Hello?
My voice is audible. Okay. So number of neurons in the input layer I'm asking. So let us assume we are trying to forecast the load on a substation based on the last 3 hours load data and also last 3 days load data. Then number of neurons in the input layer.
6. Hello? 6 parameters.
Sorry,
6
not,
neurons.
how many, sir?
6.
Yes, sir, 6. Right. So number of neurons in the input layer equal to 6. Now, how many number of model parameters that ANN will have? If you consider the bias parameter and no hidden layer.
7.
How many number of model parameters?
It should also have 6, I guess, no? 6 plus.
No, 6, sir. Actually, we have the 6 neurons right now, sir. 6 neurons in the
Yeah.
input layer and 1 neuron in the output layer. So number of weights are 6
3.
and 1 bias parameter. So total 7 model
7.
parameters we have. Total 7 model parameters we have. So in this architecture, okay. Na? So if you're not considering any input hidden layer, and if it is the problem case study, then we have the 7. But in the discussed problem, we have the only 3 features. So 3 neurons, so 3 weights, and plus 1 bias parameter. Okay. So generally, simple thumb rule is the number of neurons in the previous layer and multiplied by number of neurons in the next layer plus number of neurons in the next layer. So this is the simple formula to calculate the number of model parameters. So coming to this architecture, number of neurons in the previous layer, that is the 3, multiplied by number of neurons in the next layer, only 1, plus number of neurons in the next layer, 1. So 3 into 1, 3 plus 1, 4. Total number of model parameters are 4. That is the 1, 1, 2, 3, and 4. So that you can remember.
Okay.
So coming to this training process and everything. So what we will do now? So generally, let us assume X is the input data and your randomly initialized weights are W. So W is nothing but the W11, W21, and W31. And you have the 1 bias parameter B. And I have the linear activation function only. Now, once you feed this data and this random weight matrix and the random bias value, what is the first step? We are going to calculate the YP. So YP equal to, so what is the YP value? X1 into W11 plus, X2 into W21 plus, X3 into W31. So we can simply represent the X into W. That's it, or we need to add anything else to calculate the YP. If you want to calculate the YP, direct output, X into W only, or we can need to add anything else.
Into B.
Bypass.
Plus B, plus bias parameter B. Okay, if it is in case of the linear activation, because I'm using the linear activation function, so my output equal to X into W plus B, that is the output. Now, what is the error? So error equal to, generally we take the R-square error 1/2 into Y, that means actual output Y minus your predicted output YP whole square. Now, during the training process, we are going to update the weights and we are going to update the bias parameters such that your error should be minimized. So now again, it comes under non-linear optimization problem. So that means that's equal to 1/2 Y minus YP, that is the X into W minus B whole square. So it is again a non-linear, unconstrained, multivariable optimization problem. So how we solve this type of optimization problem using the gradient descent algorithm? As usual, you have to start with random weights and random bias parameter. And you have to calculate the output, predicted output from the ANN weights and random ANN weights and bias parameters, that is called XW plus B. Here the random initialization. Next, calculate the output. Next, what is our task? We need to update the model parameters. We need to update the decision variables. Like if suppose in the yesterday's class, minimize x square plus y square, then what we are doing? We are randomly initialize the x value and y value. Later we are calculating the delta x and delta y value. Later we are updating the x and y values like this. The same process we are going to update here. We are randomly initializing the w and b. And later what you have to do? You have to calculate the change in w and change in b. So how we calculate the change in W? What is the procedure to calculate the change in weight matrix using the gradient descent algorithm? Delta W equal to, based on the gradient descent algorithm, delta W equal to
Minus eta dou E by dou.
minus eta into dou E by dou W. So that means minus eta. So is that dou E by dou W, right? Dou E by dou W. So we have to differentiate with respect to dou W. So 2 comes forward. So it will becomes Y minus XW minus B. And anything else we have to write here?
Into minus x.
Anything else here we have to write? So minus eta dou E by dou W. I am keeping the Y minus XW minus B square
Minus
term
X.
comes forward. 2 will be cancelled. We have this one. Anything else here we have?
Minus x, sir.
Minus X. So minus X means this will become plus now and we have the X. So this is the formula we will use to calculate the change in weight. Okay. Similarly, what is the delta B change in bias parameter? How we will use? Change in bias parameter delta B equal to. So you have to remember this one. And delta B equal to minus eta dou E by dou B. So that's equal to minus eta. What is the dou E by dou B? So this 2 comes forward, 2 will be cancelled. So we have the Y minus XW minus B. Anything else?
Minus 1, sir.
Minus 1. So it becomes plus. That's it. See, if these two formulas you are able to remember, rest of things are same. What we did in the earlier class, same thing will be repeated. So again, once you got the delta W, update the W by using the W plus the W equal to W plus delta W, and also update the B value B equal to B plus delta B. That's it. So once you understand how we are getting the delta W delta B, now the rest of things are very easy. Now I will write the flow chart for the training process for the ANN model with only input layer and output layer, but with bias parameter. So you may start. So what next? So you need to read data, that is the X and Y, input data and output data. And you have to initialize eta. You have to initialize eta max. And you have to initialize number of samples, let's assume NS, number of samples in the training data. Anything else we need to initialize? Anything else we need to initialize? When we train the ANN model. We need to initialize anything else. We are reading the data X and Y. We are initializing the eta value.
Sir.
Yes, madam. So
Yeah,
it is the
done.
W. We have to initialize the random initialize the weight matrix W, and also we have to random initialize the B. That's it. So once we are started all these things, next step is we are starting with the first iteration, eta equal to 1. Later we start with the first sample equal to 1. So what next, anyone? What next? That's what happened in the backside. Actually, when we took one MATLAB toolbox and if you feed the data, it will train and give the output. But we have to know, if you are the researcher or if you are the faculty, you have to know what is happening behind. Then only you can develop some new models. Otherwise, you always using the existing models only. So if you come to know back end of the mathematics, you may develop some new models if you have interest, if you have some idea. So what will be the next step during the training process? So we are starting the first
Calculate
iteration during the first.
BW something.
We are what will be the next step here?
Calculate YP, sir.
Perfect, madam. We have to calculate the YP. So YP equal to W. Sorry. YP equal to X into W plus bias parameter B. So calculate the YP. So what next? So once we calculate the YP value, so what we have to do? I will directly do the updation. Huh? So W equal to W, that means old W plus delta W. What is the delta W value? We already calculated the formula. Eta into actual value minus predicted value into X. And similarly, update the bias parameter also, B equal to, additionally, this one is coming to picture. That's it. When compared to the previous discussion, current discussion, only this B into come into picture. So B equal to B plus. So eta into Y minus YP. That's it. So we're updating the what's called weights and bias parameters. So what next? So after updating the weights and bias parameters, what next? So we are going to update the sample count. Sample equal to sample 1. Of course, this can be done internally by the for loop. If you use the while loop, you have to do it externally, updation. So what next? We have to check whether all samples are covered or not. So current sample number is greater than number of samples. If it is yes, if it is no. If it is no, where to go now? If your current sample is not less than total number of samples, that means all samples are not covered available in the data, then where to go from here? Sample is updated, but current sample is less than the number of samples. That means still we are not completing all the samples. Then what to do?
Next sample, sir, by
Next
calculating
sample.
YP.
So we have to go to the next sample. Already we are updated, so it is going in the next sample only. So directly go to YP.
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 So if it is yes, that means your sample count is greater than the number of samples. That means all samples are covered. Then what we have to do here? So
Go to
this is the iteration. Iter equal to iter plus 1. And again check for the number of iterations. So whether number of iterations reaches the iter max or not. If it reaches the number of iter maxes, then you can check the error calculation and stop the algorithm. If the errors are not happy, then you can retrain the model by changing the some learning rate, or by changing the number of hidden neurons, or by changing the number of different parameters. As of now, that not much in this current model. Only thing you can change is eta. That's it. In the current model, very simple ANN model I'm considering, I can't change the number of neurons in the input layer because 3 features, 3 neurons fixed. I can't change the number of neurons in the output layer because 1 neuron, 1 output, that's fixed. Only thing in your control in this scenario is only eta that you can control to improve the performance. If you assume that the performance is good, then you can simply stop the algorithm. If the number of iteration count not more than the number of iterations, if it is no, where to go? If the current iteration is less than number of iter max, then we are going to
the first one before it.
we are going to the first sample again and redo it. So we have the 2 loops. So one for loop for the samples, and we have the another samples and another for loop for the your iterations. So these 2 for loops we have to write in every case, in every ANN algorithm, the 2 for loops required. Of course, you no need to write the code because many libraries are available, but we are learning all things from the scratch to understand the backend mathematics. That's why I'm telling all the things. So hope you understand this complete scenario. Now I'm trying to implement the same thing in the MATLAB, and also I'm trying to explain in the Python as well. Yeah. So come to this MATLAB once again. So this is like ANN without hidden layer with linear activation functions and bias. So this is the case 2. Slightly so previous case is so ANN without hidden layer and without bias, but with linear activation function. But now ANN without hidden layer, but with bias and linear activation function. I'm adding the bias. So my data will be available here, sample something 001. So I want to write the code. So application, I will keep it as it is. I don't want to change this application again. So I want to change this file with some name like ANN model 2. That will fit bias. Okay. You can keep underscore, not minus. Name. When we represent the name, right. So as usual, I want to start with CLC and clear all. So please, what we are going to do next? So we are just clear CLC clear all with nothing will do with the program. Just only to clear this command window, to clear this workspace. That's it. So this clear command window cleared and workspace also cleared. So what next? The algorithm perspective, training algorithm perspective for the ANN.
Read the data.
Read the data, import the data. Yes. So file name. So name of my file where my data exists. So that is sample 01. So sample 01. And so I have to read the data. What the data available in the Excel file, I want to import into my MATLAB. So I'm using the XLS read in MATLAB. When Python, it is the p.read_Excel. So pass the file name. Now you can run this code and you can see the data. You can see the data. Yes, this is the data which I want to use to train the this model. Okay, just I am removing this one. Done. So what next? Any idea?
Start
So
the
we have
iteration.
to, no, before that one, we are going to initialize. We have to
Yes,
initialize the eta value. Just I'm using the point and as a eta. And you can initialize the iter max. To iter max, I have to consider as a 100 iterations. So you have to change if the performance is not good, your error is not very high, then you can increase the number of iterations also. You can change the eta also. Only these two are in your control for this simple model to enhance its performance. So again, we have to initialize the randomly initialize the weights and bias parameter. So weights and bias parameter, I want to randomly initialize between the -10 and +10. You can choose any value. Just I am choosing the -10 and +10. In that sense, I want to randomly initialize some values for the weights. So for that, so lower limit equal to -10 and upper limit equal to +10. So between -10 and +10, I want to generate the random value for the weights and bias parameter. So my weights W equal to lower limit plus rand of. So what is the value I have to feed inside? So multiplied by upper limit minus lower limit. So upper limit minus lower limit. So because I want to generate a weight matrix between the -10 and +10, this is the code I have to write. So, but what is the shape of the weight matrix for this scenario? For our, it is a shape size of the matrix. This should be 3 rows and 1 column. So it is a column matrix, 3 rows and 1 column. So within the rand function, I have to pass 3, 1. That's it. So this is the random initialization of the W. Similarly, you can random initialize the B also in the same way. But same code I can use. So B equal to same code I can use. But where change is required, anyone can tell. I have to do slight modification in this line to generate the random B value.
Size of matrix.
Yes, perfect, madam. So actually, we have in the output layer, we have the only single output neuron. So no need to generate the 3 bias parameters. So single bias parameter sufficient. So just remove this size 3, 1. You can use 1, 1, or you can use simply 1. One value sufficient for B. So random initialization of the W and B also completed. So what next? So okay. So initialization is completed. What next? So as per this algorithm, so our initialization is completed. So what we are going to do next? Yes, sir. We have to write the for loops, outer loop and inner loop. So outer loop is for iter equal to 1 to iter max. It is the outer for loop. And inner for loop for sample equal to 1 to number of samples. How we got the number of samples? That nothing but the number of rows in the data.
Out.
In the data
Yeah.
file, how many rows we have, those are the samples. I want to keep it aside in the starting only. NS, that is the number of samples equal to size of, in my data matrix, how many number of rows are there. So that nothing but my size of the data, number of samples. Okay, so I want to write sample equal to 1 to NS. Okay, now, so two loops are initiated, 1 and 2, two loops are initiated. Next, what we have to do? Simply, we have to calculate the prediction and later we have to do the updation. That's it. We have to write the code for these two. I think you agree. We have to write the code for these two only. Okay, so now how we do the prediction? YP equal to X into W plus D. So how we got the X value? X equal to, in the data, corresponding sample, corresponding row. So I have to feed the rows. Is it right or I have to do anything change? Is it right? The statement is right. You can carefully observe here what I'm writing. Anyone can tell where I did a mistake intentionally. Anyone identified that one? So we have to multiply X into W. X means input features into W matrix. I have to add B later.
1 colon
Okay.
3, no, sir.
So in this line 15, do you identify any mistake?
1 colon 3.
Hello?
1 colon 3.
Yes, madam. So we have the only three features, right? Yeah. Fourth column is fourth column is corresponding to your output. So where is the first column, second column, third column are the features. So we have to take only 1 column to 3. So X is coming. So what next? We are going to calculate the YP. So YP equal to, how we calculate the YP? X multiplied by W plus B. That's it. That is the prediction of your neuron ANN. Simple at ANN. So what next we have to do?
W transpose
So,
won't.
madam,
W transpose won't be used.
it's not taken because I think size of W is 3,1. You can see size of W. Oh, still I am not writing this code. Let's spot here. Okay. So actually my W shape is 3,1. That means 3 rows and 1 column. Whereas X is a 1 row, 3 columns. So we can multiply 1 row, 3 column and 3 rows, 1 column. You can multiply and we have to add to the W. We will get output. It is the 1, 3. It is the 3, 1. We have the 1, 1 and 1. So we can add easily. So no need of transpose. If you do the transpose, then X is a 1, 3. Then W transpose becomes 1, 3. We can't multiply 1, 3 matrix with 1, 3 matrix. That we have to take care of it. So once we calculate the YP, now we have to update the weight and we have to update the bias. How we update the weight? So W equal to W plus eta into
Y minus.
so Y means how we get that Y value. Otherwise, I will write here Y. So how we got that Y value, actual value. Actual
Fourth
output.
column
my
of
Fourth
the
column.
data. Sample
Yes,
data.
ma'am. Put the fourth column for the corresponding sample. So this is the fourth. So now you can use that Y here directly. Y minus YP multiplied by any idea? X.
X.
But here we have to do the transpose, right? Why? Because actually this W matrix is a 3, 1 matrix. But this X matrix is a 1, 3 matrix. We can't add both. So we have to do the transpose. We have to do the transpose. Hope you understand why I'm taking the transpose. Actually, X is the 1 row, 3 columns. But W is the 3 rows, 1 column. We can't add 3, 1 matrix to 1, 3 matrix. So that's why I'm taking the transpose. Then I have the W matrix, 3, 1 matrix. Next. What next? Any idea? So this is what training is happening. How training algorithm is working backside, back end of any toolbox. But it is for the only
B.
simple neural model. Okay. Next one, B equal to,
B.
we are going to update the bias parameter. B equal to
Yeah.
B plus
B plus theta.
theta
Y.
multiplied by,
same thing.
that's it, Y minus
Y
YP.
minus predicted value.
Predicted value. That's it. So B also updated. So this process, this update will be completed for all samples and for all iterations. That's it. We are closing both.
Yeah.
So just if you see, I will stop here for some time. So no, let me show execution part. I will stop at the 13th line. Stop here. Now see the W. What is the initial W value? Not updation here. This section is not executed. Up to here it is executed. So what is my initial W? So these are the initial W, and these are the initial B values. Now I am continuing the execution. So I am continuing the execution. Then what happened? You can see. Here show the some error Y. So again, same problem. So number of rows in the second matrix. Incorrect dimensions. Matrix multiplication. Y. Size of W. Size of W matrix. So 3 rows, 1 column. And the size of X matrix. 1 row, 3 column. So transposing 3 row, 1 column. No, I'm not getting Y. It's not. NS equal number of samples, lower limit, upper limit, 3 rows and 1 column W. So recheck 1 second. Okay. Eta. So why it is coming Y value as a matrix? So, anyone can tell I did a mistake actually. Anyone identified why I got this error?
1:4 means the entire matrix.
Right, man. Actually, we have taken only 4th column, right? I forget. I didn't observe that mistake actually. Right, you can run this code now. It will work. Now it is a weight, updated weight, and this is the updated B value. Okay, otherwise we will stop here and run this one. And next step. So W, this is what the initial W value, random initialized, and B is the random initialized B value. Now continue the complete process, learning process, the training process. Now see the updated weights. Actually, we started here, and finally after 100 iterations, we are standing here. And B value minus 8 initially. Now it is the B. So 1.8775. So this is the W value, this is the B value. Right? So the training process was completed. That's it. Now what we are going to do? Now we have to calculate the errors. How we calculate the error? You can use the same piece of code. Just I already we have the time constant now. So I want to use the same code for the error calculation, mean absolute error calculation. I want to use the same code. So, but I do small modification. Where the modification is required in this code, error calculation code, where the modification is required, anyone can tell, please. In this complete error calculation code, I did some corrections in the code. This is the code which I copied from the previous one, but now I have to change it. So error calculation nothing but you have to feed the every sample input, calculate the output, and calculate the difference from your predicted output and actual output, and make it square, and later add all those things and divided by total samples. It will be the mean absolute error. But where
calculating error sample comma 3 should be there.
This one, sir. No. This one, sir. Here we have to change this one here. Because YP is not only X into W plus B also there. Right, sir? So YP equal to X into W plus B we have to keep. But I'm using only X into W only. But now we are considering the bias parameter also. So YP equal to X into W, nothing but already training was completed. We have the stable weights. Those weights I am using. And the stable bias parameter I am using. Now I am doing some arithmetic operation, small arithmetic operation. So then I will get the YP value. And later what I'm doing, I'm trying to calculate the difference between the actual value, predicted value, absolute, and adding all the things and divided by the total samples. So that will give the mean absolute error. Now we have to run this code and Till it's showing some error, we will cross it. YP. So actually, maybe I kept something capital Y. Where it is YP line number 27. Yeah, actually I'm using the small YP, na? So but here I'm using the capital YP. Just I'm reading it to the small YP. So okay. So how much mean absolute error I have? So it's almost equal to 0 mean absolute error I'm getting. So now I'm happy with this mean absolute error. Let us zoom. Just assume I'm happy with this mean absolute error. So training was completed and the errors also computed. So I'm getting the mean absolute error almost near to 0, very close. Don't expect you will get 0 always, because I'm taking the very sample specific data for this model to make you understand the process. So it won't work all the cases in the real time. You will not get exactly 0 or very close to 0. You will get some deviation. So let us zoom. I'm happy with this one. What we are going to do next? So let us zoom. I'm happy with this ANN model with the bias parameter. What is my next
Right.
task? So we have to, that's all. Training is over. Error is happy. Then we are going to deploy the model into the application. So deploy the model means what it means? What means the statement deploy the model means?
To make it
In a-
run, to make it execute.
Yeah, we have to, let us assume this is the application. You want to deploy the model into the application means you have to call this model. Call the model
this.
is nothing but just call the weights and
Weights,
bias.
weights,
Yes,
Weights.
we are just call the
trained
weights
weights.
and biases. So this is the weight matrix. So just Control C. So just call these model into the application. So can call it as a. So this is the weight matrix. Okay. Not only weight matrix, because now your model contains a bias also. Now you have to call the bias also. So what is the bias value? So updated bias values are already maybe somewhere available here. So this is the updated bias value. Just call that one also into your application. That's it. So deploying a model is nothing but just to take your weights and bias parameters and push it to your application. And that application will use your weights and bias, nothing but will use your ANN model. What or machine learning model, what you want to call, you can call. That's it. So again, you are giving the permission to user to enter the value of x1, x2, x3, and anything else we have to do here. What change I have to incorporate here, or you can keep it as it is. 6th line. We're going to predict based on some inputs. I'm going to predict the output.
Plus B, sir.
Yes, madam. So plus bias parameter we have to add. That's it. Now simply that application is readily available now. So we will check with some data which we are using. Where it is NNL data and I think 0.1. So let us I want to keep the 0.1, 0.2 and 0.3. So just run this application. It is asking for me. So what is the value of the x1? So I want to keep 1.1 and x2 value 0.2 and x3 value I want to keep the 0.3. Now I'm getting the 4.26, almost close to the 4.3. So that's why how the training was happening for a ANN model, simple ANN model with a single input layer and output layer and bias parameters, and how the training process happening, how we calculate errors, how we deploy the model into the application. So I hope you understand this too. Now I'm trying to execute same thing in the Python also. Already shared this notebook with you. So as usual, simply you have to import the data because my data is available under the sample data _01. So run this model, try to import the data. See, I'm using in the MATLAB, we are using the XLS read. In the MATLAB, we are using the XLS read, but in the case of the Python, we are using the So in the MATLAB, I am using the XLS read, whereas in Python, I am using the pd.read_excel to read the data from the Excel and assign to some variable. So data was imported into the Colab notebook. Later, we have to split the data. That what not performing in the MATLAB now. In the MATLAB, when I'm writing the code, I am using the whole data for the training purpose only. But generally, so whole data should be splitted into the training and testing based on some percentage. So I'm using the train_test split method and keeping the test size as a 0.05. That means 5% of data should be used for the testing and remaining 95% of data should be used for the training. And data_train will contain the training data. Data_test will contain the test data. Okay. So this what the same code I'm discussed in the earlier case. So what next we are doing? Randomly initialize the weights and bias parameters. You can see the random initialization of the weights and bias parameters. So weights equal to np.random initialization of the weights between the -10 and +10. Size is 3,1 because we have the 3 input neurons and 1 output neuron. So 3,1. And bias equal to random initialization between -10 and 10, but size taken is the 1,1 because we have the only one bias parameter, that too at the output layer. So the random initialization. That's it. These are the weights. First 3 values are the weights, and this one is the bias parameter. Now this is the learning algorithm. So because for me in the MATLAB, I check here. So it's working well with learning rate of 0.9. So here also I want to take the learning rate of 0.9. If it's not performing well, you can tune it. And I'm running this algorithm for the 10,000 iterations, or you can use the same 1,100 also, that what we are using in the MATLAB, or you can use the 10,000 also, no issue. So this is my outer for loop for the number of iterations. And this is the inner for loop based on the number of samples. Range Q1. Q1 means, see, Q1 means length of the training data. That means number of samples in the training data that represents the Q1. That means NS, number of samples. Okay. Now how we calculate the O? O minus OP, predicted output. So predicted output equal to NP dot, that means matrix multiplication between the your X. You can see X value for the corresponding sample J. In the data training data, corresponding sample J, 0 to 3. That means 0th column, 1 column, 2 column, 3 is excluded. So 3 column, that is the X multiply with your weights and add the bias parameter. That will give the YP. That means O in this case. And later what I'm doing, what I'm calculating is I'm calculating the delta W, I'm calculating the delta B. How we calculate the delta W? Delta W equal to eta, learning rate. The third column, what third column represent? It is the actual output. Minus O means predicted output. So eta into, I will show my whiteboard now. So delta W, this part, eta into actual output minus predicted output to X. So delta W equal to eta into, this is the actual output, third column, and O is the predicted output coming from here, multiplied by X. X means under the data train data, corresponding jth sample from 0th column to the 3rd column. So 0, 1, 2 features. But I am going to transpose it. Okay. So similarly, what we did here also we are going to transpose. Where it is? Yeah. Here we are transposing the input. Similarly, here also I am transposing the input data. So that is the delta W. And similarly, you have to calculate the delta B. So delta B equal to your eta learning rate multiplied by your actual output minus your desired output. That's it. You can see the whiteboard. So B equal to B plus eta into Y minus YP. Delta B is called delta B. So delta B equal to eta into Y minus YP. So delta B dB equal to eta into Y minus YP. So once you got the delta W, delta B, now update the weights. Weights equal to weights plus delta W and bias equal to bias plus dB. That means delta B. So this process will be repeated until all samples are covered and until all the iterations are covered. So just simply run this code. That means training process is happening. So once the training is over, now you have to do the testing. Testing means you have the one data in the testing, one sample in the testing data. Na? So feed that sample and calculate the output. So output calculation, I think, but the matrix multiplication between your X, matrix multiplication between your X and weights and add bias. That is your output, predicted output. So this is my predicted output, 7.32 something. And if you know the actual output, if you want to see the actual output on the test data, it is 6.1. And here we are getting the 7.32, slight variation because you have some error, something error we are having here. That will calculate later otherwise. So next one is testing data. Now see that testing error. So we are getting some testing error like, so see, yeah, so I forget one thing. So see, here I am using eta as 0.9, not 0.09. So because of the learning rate variation, I am getting some error larger than what you are seeing in the MATLAB. So I have to keep not 0.09, I want to keep the 0.9. And again, I want to initialize my weights and restart my training process because I'm not happy with my error. I'm error around 1.5, more than 0. That's why I'm retraining my model. Reinitialize the weight parameters, bias parameter, and retrain the model with learning rate 0.9. And now predict the output with the testing data. I'm getting 6.11. So you can see the test data. You also have the 6.1. Now you can see the error. Error means mean square error. That is nothing but the difference between your actual output and your predicted output. So you are getting 0.00001. So almost close to 0. And also you can check with the training data. You have to pass all the training data and calculate the corresponding output. So for all the training data samples, these are the outputs predicted by using your model. And now you can calculate the error also, mean square error by passing the actual training output and also predicted output using the training data. So it's also near to 0. Now we are going to deploy the model. Deploy the model is nothing but just keeping the weights and bias what we are getting from this training algorithm. From the training process, we are getting the weights and bias, right? So those weights and bias parameters are using here. And we are giving the permission to the user to give the input, enter value, and that values will be feeded between the as a matrix multiplication between your input and weights plus adding the bias parameter. Just run this one. Now it will ask some values. So we can use same 0.1, 0.2, 0.3. So one feature is 0.1. One feature is 0.1. Second feature is 0.2. And third feature is sorry, I mistakenly added. Otherwise we can try. So maybe something happening here. Okay. Think. So enter the 0.1, x1 value, x2 value 0.2, and x3 value 0.3. So it's giving something around 3.0. So something problem happening actually somewhere. One more thing. So the errors will be different for the different scenarios. Anyone tell why that was happening like this? Sometimes I'm getting the error almost equal to 0. Sometimes when I'm retrain it, I'm getting the some other error. Any reason? Anyone identify what is the reason behind it?
So because it is randomly taking the values.
Perfect, madam. So we are initializing the weights randomly. So that sometimes that variation will be coming. From where we are starting, that will be changes at every training. So sometimes your weights and bias parameters are very far from your optimal point. So over the 100 iterations may not be, it will reaches that optimal point or not. That is the reason why. So we are getting the different errors at the different scenarios during the training process. So because your random weights are, there is the random weights. So one time some weights are generated, another time some other weights are generated. So this is how the working of the ANN model with hidden layer and sorry, without hidden layer, but with output layer and bias parameter. So only with these two architectures, we completed